this video, I am going to address one of the most pressing challenges of our time, reducing carbon emissions from thermal power plants and transforming this emission into valuable products. I, on behalf of Team EnergizeX, is excited to present our innovative approach to carbon capture, utilization and storage, or CCUS. The world is facing a severe climate crisis, and thermal power plants are major contributors to CO2 emissions. Our objective is to not only capture this CO2 but to convert it into products that can drive economic growth while significantly reducing greenhouse gases. We have developed a four-step CCUS process. The coal combustion gas released from the thermal not only contains carbon dioxide but also contains some other gases such as sulfur dioxide, nitrogen oxide, and some other gases as well. So to capture the carbon dioxide from this gas, we need to do a process known as liquefaction or scrubbing technology. The coal combustion gas is passed through a scrubber for purification to achieve the required purity level. Then it is passed to the separator to separate the CO2 from other impurities. Then it is passed through a compressor and a dehydration chamber and then further into a cooling chamber where the gas changes into liquid state. CO2 is cooled to approximately minus 20 degrees Celsius to minus 30 degrees Celsius at a pressure of around 20 bar. At this point, CO2 transitions into a liquid state. Liquefied CO2 is stored in insulated pressurized tanks that maintain low temperature to keep the CO2 in its liquid form. Finally, the stored CO2 is utilized in various applications. CO2, when reacted with hydrogen, forms syngas. When the syngas is further passed through the catalyst field tubes under high pressure, it forms hydrocarbons. The hydrocarbon, on further refining, form jet fuels and some other products like paraffin wax, etc. CO2, when injected into aqueous electrolyte, it reacts with the cathode, turning the solution more acidic, which in turn generates electricity and creates hydrogen. CO2, when injected into mature oil fields, reduces the viscosity of the oil, helps in increasing oil recovery. CO2 can be converted into synthetic fuels such as methanol and ethanol through chemical reactions. The feasibility of CCUS is demonstrated through its multiple applications. The technical feasibility of CCUS is that CO2 can be transformed into jet fuels. It can be used to form hydrogen. It can help to reduce the viscosity of the oil, improving oil recovery, and also formation of synthetic fuels, providing the technical soundness of the approach. Talking about the economic feasibility, there is a growing demand for sustainable products such as carbon neutral fuels and CO2 derived building materials, so the market demand for CO2 derived products is high. It also has cost reduction potential. Technological advancement, improved capture efficiency, and scaling up production processes have the potential to reduce cost over time. Talking about the viability of CCUS, the economic viability is that converting CO2 into fuels, chemicals, and materials offer new revenue stream that can improve the viability of CCUS project. It can also help in reduction of greenhouse gases. It can also help us scale up new innovation. The impact of CCUS on the environment and economy is profound. Reduction in CO2 emission. CCUS captures up to 90% of the CO2 emission from power plant and industrial processes, significantly reduce the carbon. Support for net zero targets. Many countries and companies have committed to net zero emission by 2050. CCUS is essential for achieving this target. Extension of fossil fuel use with reduced impact. CCUS allows for continued use of fossil fuels in a cleaner way, supporting energy security during the transition to renewable energy sources. The benefits of CCUS is profound too. First is the economic opportunity and job creation. The deployment of CCUS infrastructure can create new jobs in engineering and construction and operation. It also provides opportunities for innovation and development of new technology. Second is the decarbonization of industrial sectors. CCUS is crucial for decarbonizing sectors like steel, cement, and chemicals, which are difficult to electrify. This contributes to the overall industrial sustainability. Third is it helps in climate change mitigation. CCUS helps mitigate the impact of climate change by reducing greenhouse gases concentration, contributing to global efforts to limit temperature rise in the line with the Paris Agreement. To sum up CCUS, CCUS is more than just a technology, it's a pathway to sustainable future. It allows us to continue using fossil fuels more responsibly while advancing towards our climate goals. By capturing, storing, and utilizing carbon emission, we can turn a global challenge into an economic opportunity. Thank you for your attention, and we look forward to your feedback and support as we move forward with this innovation.